The starting point of the simple regression is that due to some reason or theory, we believe x and y has a relationship, which means the value of the y is depends on the value of the x. So we call the x is an independent variable or the predictor. And then we call the y is a dependent variable or the response variable. Predictor variable, it means we can use the value of the x to predict the value of the y. For the response variable, it means when the value of x increased, the value of the y will make a relatively response. And in here, we believe we know, due to some reason, we know that is a right relationship between the x and the y. In this case, we assume the b0 equal to 1, b1 equal to 0.5. And for the x, we believe we give them 50 observations for the x, and it is follow the normal distribution. However, for the y, this relationship is a unknown, which means not anybody knows them. When we are doing the simulation, we know what is the value for the b0 and b1, but in the real world, we don't know these two values. What we do is we try to use some equations in here to estimate these two values. This is more like play a game. In this case, we know the right answer. So what we do is we give the value of the x and y to the computer and ask him to see whether they can give us a good result. And in the real world, nobody knows the real answer. So what we do is we have only the value of the x and the value of the y. And then we try to estimate something we don't know, but we believe they should be there. So because when we have the x and when we have the y, but so the value of the y may not really exactly equal to the y in here, because there are some error terms. There could be some errors. For example, like when we get the sample, they are not really randomly selected, or somebody they made a mistake when they collected the sample. So which means we allowed the y is could be different from the y from the theory. So in here, we assume the error term, the epsilon, follow the normal distribution. The mu equal to 0 and sigma equal to the 1. And the y is depending on the x and the error term epsilon. So now let's try what we have so far. This is a histogram of the variable of x. It is a normal distribution. And this is the theoretical model. Actually, in the real world, we don't know it. But when we do the simulation, we can assume that we know it. So in here, the intercept is a 1, and the slope is 0.5. So now what we have is we have the x and the y. And for this part, what we are doing is rely on the x and the y. We try to get the estimated value for the capital 0 and capital 1. And we try, if we have the capital 0 and capital 1, we can get the predicted y, and we can get the predicted epsilon. For these several equations, they are from the textbook. And for these three equations will be used to calculate the correlation. And this is the formula or the equation to calculate the beta 1 and beta 0. Okay, our estimated coefficient is 1.27 and 0.33. So actually this is different to the value we given in the theoretical model. We don't know in the real world we don't know these two parameters, but now when we do the simulation, we know we give the value is 1 and 0.5, and then based on these several equations, the estimated coefficient is 1.27 and 0.33. But actually, this is not really a bad result if I consider there are only 50 observations in the x and the y. So now we have the estimated parameters, and we have the x. So which means if I put each value of the x into this equation, they will give me a value of the y. However, very probably the predicted y, it will be different with y from the first part, because this coefficient is different with the parameter we given. So now let's calculate the y hat. Y hat equal to the x times the beta 0 and beta 1. And the e, that is the estimated error term, or the estimated epsilon, is based on the y minus y hat. And this is the standard deviation, square root of the error terms. The sum of the error terms is the standard error of the estimation. Okay, so on this graph, the red line is the true relationship, which is from the theory. During the simulation, we gave them the value is 1 and 0.5. And the black line, that is the estimated relationship. This black line is based on the 1.27 and 0.33. And on this graph, the bigger point, they are the residue, or they are the estimated error term. And the true value of the error term is in the blue, the circle. So actually you can see some of them, they are close to each other. Some of them, they are almost exactly equal to each other. But however, for some of them, they are a little bit far. So now what we have did is that when doing the simulation, we create a world. We believe we know everything. In this world, we know everything. And we have the x, we have the y. When we generate the value of the y, we put some error terms into here. And after that, we will have the value of the x and y. If you go through the textbook, they don't go through this part. They just told you, okay, due to some reason, and we believe that is the relation between x and y. But unfortunately, nobody know what exactly the relationship they are. And in our questions, they just give you the value of the x and the value of the y. So when we have the value of the x and when we have the value of the y, we can get the estimated coefficient. We call them the beta 1 and beta 0 through these several formulas. And it will be here 1.27 and 0.03. So 0.33. And we know we have the value of the x and the value of the y. And if I give you the estimated coefficient, you can get the estimated y. And if you have the estimated y, you will get the estimated error term. And we give them a name, we call them the residue. So on this figure, the black line is based on the estimated y, and the real value of the y is on the red line. So you can see they are slightly different. However, you can see the regression line is always go through the average of the x and the average of the y. And when we have the estimated y and the true value of the y, the different will be the residue. That will be the estimated error term. The estimated error term in the cycle is from this equation in here. Is generated from the normal distribution. And for the bigger point, the thick point, they are the y minus y hat. And that is the whole story for the simply regression.